Okay, so it's just going to go live for a bit, see if any of you got any queries. Just going to sort out my sort out the image. Okay, so I've had got a question sent through by Zoe, which we'll have a look at. I've also got a couple left over, spotted that Zoe sent through the other night that I didn't notice. So I'll look at those too. Hi, Louis. Shout out to Louis, who's the first to come on. Good, Louis, I'm glad you liked your shout out. So once I know that Zoe's on, I'll run through the questions she asked for. Hi, Zach, shout out to you as well. So this is primarily not aimed at my first formers just wanting to get a shout out, though that's absolutely fine. This is mainly if any people who've got their GCSE tomorrow morning have got any last minute questions. So you can either just tell me what paper it's from, if it's from a recent IGCSE or GCSE. I've got most of the recent past papers here. Or if you've got a specific question, just take a photo of it and tweet it to me at my Twitter account, which is at Maths by Mr. W, and then I can pick it up from there. So feel free to do that. The question I've got in front of me, as I said, I'm just thinking of doing this if Zoe comes on. So I'm just going to see how to do it. But as I said, if you've got any questions out there, oh, hi Zoe, you're there. Right? That's good. Okay, so what I think I'll do, Zoe, I might just start with the two that you sent through the other night. Can you just confirm if you still need those two? It was these two. Hi Alfie, all right? So the two you sent through the other night with that one there, and that one there. So can I assume? Yeah, you're saying yes, please. So I'll run through both of those first, if I may, because I've had a chance to look at those already. So I actually I can do those. Okay, right. So I think what I'll do, Zoe, we'll get the hardest one out of the way first. Alfie, you're asking how long is this going to be? I don't know, really. We'll see how we go. We'll see how many questions we get. So I'll half an hour or so. So right, Zoe. So we're going to do this question 15. There are only n red balls and n+1 blue balls in a bag. Shamsa takes at random 2 balls from the bag. Show that the probability that both balls are the same colour is n over n+1. Now this is tricky. So so we'll see how we get on. So we're going to show that they're the same colour. So if they're the same colour, then they're either going to be red and a red, or they could be a blue and a blue. Okay, so let's work through both of these. So we've got, so if we go and take a red, okay, if the first pick is going to be, there are only red balls, there are n red balls and n+1 red balls. Okay, so the probability of a red with our first pick is going to be, the probability of a red is n. This is our first pick over how many balls are there to start with. Well, there's the n red balls and n+1 blue balls. So with that first pick, the total number of balls is n plus n+1. So that's n being the number of red balls over n being the red balls and n+1 the blue balls. So that's the probability of getting a red with our first pick. Now with our second pick, there's obviously one less ball in there. So one less red in there. So the chances of picking a red with our second pick is going to be n plus 1. And there's one less ball in there now. So rather than n plus 1 balls, there's now n plus n balls. This is the probability of a red and then another red. And then we've also got a probability of a blue and then a second blue. So the probability of a blue with our first pick is n plus 1 out of the reds and the blues. And then a blue with our second pick is going to be 1 less than n plus 1, which is n over our n plus n again. One less ball in there now. So that's our starting point. So if we just tidy that up, we got n over 2n plus 1 multiplied by n minus 1 over 2n. And we're going to add on to that n plus 1 over 2n plus 1 multiplied by n over 2n. So we've got a common denominator here of 2n plus 1 times 2n. So we've got a common denominator here. So on our numerator is going to be the top bit. So n times n minus 1 plus n times n plus 1 all over 2n plus 1 2n. So multiply that out. We get n squared minus n plus n squared plus n all over our 2n plus 1. I've just written that down around the other way. Now those n's cancel out. So we're left with 2n squared over 2n plus 1. Now those 2's cancel out, and one of these n's cancels out. So that's leaving us with n over 2n plus 1, which is what we had to show. Now that's really difficult, so don't beat yourself up if you can't do that. This was off a GCSE paper, by the way. So those of you who are doing the IGCSE, I think it's unlikely we'll get anything as difficult as that. Okay, so that was one from the other night, Zoe. Right, your second question from the other night. If you want me to come back and put that one back up on the screen a bit later, just let me know. So this was the second one that you mentioned. Okay. Now, this is for GCSE, so you don't have to differentiate for GCSE. So those of you who are doing the IGCSE, oh, good. I'm glad you understood that first one, so that's great. So with this second one, anybody who's watching is doing the IGCSE. This can be done really quickly by differentiating, which is part of the IGCSE. But Zoe, who's asked for this question, is doing the GCSE, so I'm assuming she doesn't know how to differentiate. So I think the best way to do this, if you don't know how to differentiate, is just to rely on the symmetry of the parabola. So doing this by symmetry, we're going to start off by finding out the 2 points where the curve crosses the x-axis. So we're going to solve this equaling 0. So we're going to solve 80t minus 5t squared equaling 0. Ah, Zoe, you do further maths. So can I assume you know how to differentiate? Oh, you do? Okay, right, okay. Right, let's scrap this. Let's scrap doing it by way of symmetry then, and let's just differentiate it. So at the maximum point, we've got obviously the gradient equals 0. So we can just differentiate this and set it equal to 0. So ds dt equals 80 minus 10t. Okay, so the 80t's become 80, and with the second term multiplied by the current power, so that's minus 10, reduce the power by 1 to 10t. Okay, so we're trying to find out whether the gradient equals 0 at the maximum. The slope is 0, so we set that equal to 0. Okay, so from that we can see that so 80 minus 10t equals 0. So add 10t to both sides, so 80 equals 10t, so t equals 8. So we've got, so our greatest distance is going to be when t equals 8. So if we substitute 8 back into our distance function, so s equals 80t minus 5t squared. If we substitute 8 into this, we get 80 times 8 minus 5 lots of 8 squared, which is 640 minus 320, giving us 320. So that would be the answer for that one. Whoops, sorry, that just popped off the screen. Okay, so we've differentiated, set it equal to 0 to get t being 8. We've substituted our 8 back into the function, back into the s function. Be careful, don't substitute it into the differential, substitute it into this function, and we get s being 320. Okay, 2 from the other night, and now I'm going to have a look at your your vectors once sent through, which I haven't had a chance to prepare this one, so let's just go and see what we've got. We've got CA equaling 3a, C to A being 3a, C to B being 6b, and B to Y being 5a minus b. And we're told that x is the point on AB, such that AX to XB is 2 to 1. Right. So let's go and say that X is there, and A to X, oops, I've gone too far. Let's put it down here. So A to X is 1 mile, A to X is 1, while X to B equals 2. And we've got to prove that CX, so that's CX there, we've got to prove that CX is 2/5 of CY. God, that's difficult. Okay, right. So what we're going to do, let's first of all work out what the vector C to X is. Okay, let's try and do C to X. Now, to do C to X, I am going to go from C to A and A to X. Simple enough. C to A to X. Now, what do I know about the length AX? Well, AX is 1/3 of AB. So I can say, I can replace that A to X, which is this 1 mile, by saying it's 1/3 of A to B, which is 3 miles. Now, I've then got to see, am I able to move over to little a, little b format? So C to A, yeah, that's 3a, and A to B, well, that's going to be A to C and C to B. So yes, I can. So let's just move over to using little a, little b format. So C to A is 3a. And I need to have 1/3 of A to B. Now A to B is, so let's just do this as a side working. A to B I can do by going A to C and add on C to B. A to C is going down this the wrong way, so that's minus 3a, and C to B is a 6b. So basically my AB is a minus 3a plus a 6b, so I can include this here. Okay, so let's just summarize that. We're saying that to go from C to X, I'm going C to A, which is 3a, and A to X, which is 1/3 of A to B, and A to B is minus 3a plus 6b. Now it's just algebra from now on, so let's just do this claw here. So we've got 3a, 1/3 times minus 3a is minus a, and 1/3 of 6b is 2b. Let's then gather up our terms here, and we get 2 lots of a plus 2 lots of b, and that's factorize that, we get 2 lots of a plus b. So C to X is 2 lots of a plus b. Now let's go and focus on what CY is. This is going to be, so C to Y Now I'm going to get C to Y by going this way. Okay, so I'm going to go C to B, then B to Y. That's because that's down roads that have got A's and B's on already. So C to B is 6B. B to Y is 5A minus B. Gather that up, 6B take away B is 5B and my 5A, so that's 5 lots of A plus B plus 5 lots of B. Factorizing that, we get 5 lots of A plus B. And I can already see that that's good. That's going to be really handy, isn't it? Because I can already see that my C to X is 2 lots of AB. My C to Y is 5 lots of AB, so I'm pretty much proving this already, aren't I? So what I'm saying, so I can then go and say, that's great. So I can go and say now that CY equals my 5 lots of A plus B. So 2/5 of C to Y is 2/5 of this. Which is 2 lots of A plus B. And that equals CX to A plus B. And therefore I've shown what I had to show. Right, so I'll just leave that on the screen, just to leave, allowing anyone who's watching to digest that. Let's just try and get a bit better on the screen. Now, it's a very difficult vectors question. I think don't panic if you're last minute and you can't do that. This is really at the top end if you're trying to get an 8 or a 9, I would say. I mean, all these questions we're looking at here are the top end. Okay. Okay, so Zoe's saying long process, but I did get there. Thank you. I got a few of the steps. Well, if there aren't any of those steps you understand, just elaborate. I don't think there's a quicker way of doing that. Okay, just to summarize, if we've got to prove something like this, you've got to really just start off by working out what CX is, working out what CY is, taking 2/5 of CY, and just hoping it equals CX. Okay, and then you've just got to work through that process. So, I mean, obviously, if you need you can play this video back later if you just need to go over that again. So I think that gets me up to date with all the questions that have been sent through to me in advance. That's the 2 from Zoe from the other night and the one she sent through just before tonight's. I can see there's only 5 people watching here, which is fine. Hopefully you feel you're fully prepared, so you don't need to do any last minute questions. I think what I'll do, I'm going to stay online another 5 minutes or so, just in case anyone else has got any last minute queries. So if there's anything on any of the recent GCSE papers or IGCSE higher papers, I've got those here, so you can just tell me which paper and which question you wanted to do. I'm just checking my Twitter to check nothing else has come through. Okay, so someone else has just sent through a question. Gosh, again, it's a really nice, difficult one. Let me just all right, I'm just going to run off this question that's come through. Okay, so I'm just printing off a question that came through from somebody. Okay, so this question here was printed out a very good way there, have I? All right, this question came through. Okay, came through from somebody, so I might just run through this shortly. Okay, I can't remember who it came through from. So if you sent this through, got a feeling it was somebody called Piggy Wiggy or something, which is, I doubt is your real name. So if that person online just wants to just say that, yeah, they're watching, then I'll go through it. That's I mean, I'll go through it anyway, but I might as well wait till the person who sent it through confirms they're online. So I'll just give that a minute or two. While I do that, let me just read through what's come through. Zoe said, is there any formula that you think would definitely come up tomorrow that we should memorize? Well, yeah, I don't know about you. I'm a real big fan of y minus y1 equals x minus x1, which allows you to work out the equation of any line when x1 points on any point on the line and m is the gradient. So if that's something you've come across in your travels, Zoe, I would definitely make sure you're okay with that. For anyone who's seeing that first time, don't panic, just don't use it. Just sort of use y equals mx plus c, and you can normally work your way around it. But I'm a big fan of y minus y1 equals x minus x1. Let me think. You're doing the GCSE, aren't you? So we say you think you're going to have to learn the quadratic formula, aren't you? So hopefully you're okay that that's minus b plus or minus the square root of b squared minus 4ac all over 2a. Those of you doing the IGCSE, that's still given, so you're fine. Do you think it's a good idea to learn the exact trig ratios? I personally don't. I mean, I think as long as you know how to actually derive them quite quickly, I would be pretty chilled about that, Zoe. So so what I would, just to check, Zoe, are you okay that if you have to go and work out the exact values of the trig ratios for 30 and 60, just make sure that your starting point is to draw an equilateral triangle with lengths, so the angles are all 60, okay, equilateral, and give the lengths of 2, okay, drop down a perpendicular, so that then means our angle at the top is 30 degrees, because it's half of the 60, and then work out the length of this side here using trig, okay, because we're saying this little length here is 1, because the whole length is 2. So we can work out this length here using, sorry, not trig, using Pythagoras. So this length here, Pythagoras, you can say x squared equals 2 squared minus 1 squared, which equals 3. So x equals the square root of 3. So that length is the square root of 3. And now you can go and work out all of the trig ratios. So if you needed to work out sin 60, it would be your opposite over your hypotenuse, root 3 over 2. Cos 60 would be your adjacent over the hypotenuse, 1 over 2. Tan 60 would be opposite over adjacent, which would be root 3 over 1, which is root 3. Similarly, from the 30 degrees point of view, sin 30 would be opposite over hypotenuse. A half. Cos 30 would be adjacent over hypotenuse, root 3 over 2. And tan 30 would be opposite over adjacent, which is 1 over root 3, which, if you know how to rationalize a surd, happens to be root 3 over 3. So do make sure that you can recreate, so you can quickly calculate the exact ratios, okay? But I wouldn't personally spend a lot of time just absolutely learning them. Right. Oh yeah, Jonathan, did you get my my Twitter message. Yeah, I think I did. Was it that question, Jonathan? Because if it is, I'll go through that. I wasn't sure if it was you. So if that's oh right, okay. I know you sent me some the other night. If you let me send us, I'm just going to have another check. I see another message has come through. Let me just see if that's yours. Messages, notifications. No, it should be messages, shouldn't it? Oh yeah, sorry, Jonathan. I can see it there. Sorry, I missed it. You sent it through 11 minutes ago. Right, let me just. Right, okay. Let me see. Oh yeah, this is quite a short one. Let me see if I can just read it. So right, is it part to Jonathan? Is it? I see. Right, 1/32 is a power of 2. Do you want A and B, or is it just part B? What I'll do, I'll just run off that question while I'm waiting for you to get back to me. So, oh, just A. Okay, if it's just A, then that's fine. I can do that without running it off. Okay, so you're asking for. The question says write 1/32 as a power of 2. That's the question. Okay, so first things first, that 32 is 2 to the power of something, isn't it? 2 2s are 4, 8, 16, 32. So 1/32 is the same as 1/2 to the power of 5. And then if you take this upstairs, that is equal to 2 to the power of -5. Okay, so I don't know, I can't remember, Jonathan, if you're GCSE or IGCSE, whether you're calculator or non-calc, but basically if you're on a calc paper, you can just check that. You go 2 to the power of -5, and you get 1/32. Oh yeah, IGCSE, okay. So anyway, that's how you do it, okay? And then obviously, as you've got the benefit of a calculator, you can just check that. So just pop into your calculator 2 to the power of -5. 2 to the power of -5 equals, and that gives you a decimal. Press the SD button, and it takes you back to 1/32. So yeah, you can send through another question if you want. I don't mind giving it a few more minutes. So basically, so Jonathan, you're all right, and you're okay with part B. So that was part A sorted. So I'm not going to run your question off, Jonathan, because right. So I'm just going to wait for Zoe's second question to come through, and I think after that I might call it a day. I'm getting tired. Right. So let's go back to messages. Yep, it's come through. Oh, bloody hell, this bloody exponential master rabbit questions. Here, 3, there were 529 rabbits. How many rabbits were there by year 5? 8. Okay, gosh, I haven't done one of these for a long time. So what it was saying, year 1, yeah, so what are we saying? We're saying 400 multiple. Oh, do you know, I can't remember how to do these. How does this work? I think we're saying right, I think, again, I could be wrong here. I think we're saying in year 1, so we've got a constant times x to the power of 1 equals 400. Are we then saying in year 3 is a to the x to the power of 3 equals 5? No, I don't think we are. That's not right. Are we saying that? If we were saying that, we would do, I'm not sure this is right. If anyone out there knows how to do this, can remind me, let me know. Let me think. If we do 2 divided by 1 now, we're going to get x squared equals 529 divided by 400. Let's see if that gives me a sensible number. 1.3225. And if we square root that, oh yeah, we do get a nice number. That may well be right then. I think what we're saying is that our formula for the rabbits is, yes, I think that's right. So I think we're saying we've got an unknown constant, and then x to the power of 1, because we're in year 1, is 400. Then in year 3, x to the power of 3, because we're in year 3, is 529. And by dividing 2 by 1, that eliminates a, because a divided by a is 1. So we get x cubed divided by x to the power of 1 is x squared, and 529 divided by 400 is 1.3225. Square root that, we get x being 1.15. If we then go back and substitute that into either of these equations, let's say that first equation, we're saying a times 1.15 equals 400, allowing us to work out that a is 400 divided by 1.15. Which is 400 over 1.15. I think that's right. So on that basis, we would be saying in year 5, we're going to be saying a, which is 400 over 1.15, multiplied by by x, which is 1.15 to the power of 5. I think that's what we're saying. So we would get 400 divided by 1.15, which is a, and then we're going to multiply that by 1.15 to the power of 5. And that gives us 699.6025 rabbits, so 700 rabbits. I know it's not great, Zoe, that I don't know that completely straight away off the top of my head, but I feel a bit rusty on these. But I think that must be right, because if it's exponential, we're saying that it's the power is the variable, isn't it? And I feel that could well be right, because I've got a nice x number. I've got a nice value for x. So I think that's right. I don't know what you think, Zoe. Does that sort of make sense? Oh, I do need to just slightly move that up a bit. Sorry. For those of you who are doing the IGCSE, don't worry, exponential graphs aren't in it. And I think that's why I'm a bit rusty, because I haven't taught the GCSE for a year or two. You think it's 400? Right, let me see. Could you be? You think A is 400? No, I don't think so, because in year one, we're saying that x is 1.15. Yeah, no, I hear what you're saying, but that's what you're starting with, yeah. But then don't we then on that basis then have to say, if we're saying year 1 is basically our naught, I would have thought we then have to say by year 3 that, oh yeah, you might be right. Let's have a think about what you're saying. So you're saying our a x to the naught is basically 400, and then our ax squared would equal 529. No, you could be right, Zoe. That would make sense, wouldn't it? That would make sense. So we then still go through the division, which would still give us x squared equaling 529 divided by 529 divided by 400. So that would still be 1.3225. So x is 1.15. I think you're right, Zoe. So our formula is actually 400 times x to the power. Okay. But then on that basis, you would have to say how many rabbits were there by year 5. You're then going to have to put in to the power of 4. Okay, because if we're saying year 1 is when our power is 0, year 5 our power would be 4. So I think on that basis, we should be saying it's 400 times 1.15 to the power of 4, not 5. 400 times 1.15 to the power of 4. Oh yeah, that gives us the same answer. Yeah, we're getting the same answers, are we? Still getting, yes, of course we are, because that's basically cancelling. Yeah, of course we are, because we basically got a 1.15 there, and we're just knocking out one of those powers there. So either way, we get 700 rabbits. Right, what else has come through? Oh, great. Alfie says, I agree, because this is correct. Well, thank you, Alfie. So, yeah, I think that's right. What did you say your predictions were? I have no idea. I really don't know. I mean, obviously the IGCSE, it's a brand new paper. GCSE, we're only into year 2. If you're doing the IGCSE, who knows? I hope it's just like the paper last summer, and that we had and the real papers in summer and January. I think they're fine. I thought the mock and the specimen were quite tricky. Right, Alfie just asking, solving simultaneous equations using graphs. Okay, well, I haven't got a question to hand, okay, but it's dead easy. You just basically look where they cross, okay? So if you've got, it doesn't really matter what you've got. If you've got, I don't know what your graphs are, but if you've got a curve and a line, then you basically, if you're using graphs, you would just simply read off those two solutions to get to solve it by graphically. So if that coordinate there was 3, 3, 5, and that coordinate there happened to be, I don't know, 8, 7, then your answers are going to be x equals 3, y equals 5, and x equals 8, y equals 7. Solving simultaneous equations using graphs is as easy as that. It doesn't come up very often. You've just got to read. No, that's a separate. Alfie's now saying so the minimum point is the lowest one. No, I'm not saying that. I mean, the minimum point would be there, wouldn't it? The minimum point there. I'm just saying that's not a minimum point. That's just where the curve is crossing the line. Finding a minimum point finding the minimum point on a graph is a separate thing. You can either complete the square, or if you're doing the IGCSE, you can differentiate and set it equal to 0, or you can find where the graph crosses the x-axis and then use the symmetry to go halfway along. So there's a number of ways of doing it. Okay, right. I think I'm done now. So good luck tomorrow. Okay. I will. I think the second paper is. Yeah, good luck, Zoe. The second paper is like Thursday fortnight, isn't it? We've got half term, and then it's the Thursday afterwards, and then even later again for you GCSEers. What I'll do, I'll stream again on that week leading up to the second paper. Okay, so good luck, guys. You've worked hard, I'm sure you'll be fine. And just remember, if it's a real nightmare of a paper, then everybody else is finding it a nightmare too. Okay, all the grade boundaries will come down, they have to. So if you're well prepared, just chill, try and get a good night's sleep, and you'll be fine, I promise.